Factoring by grouping. So it says so far we have only factored trinomials. We will now factor polynomials with 4 terms by this method called grouping. Okay, and I have this little note here. Not all 4-term polynomials are factorable by grouping, but I carefully designed these problems to be able to. So in Algebra 2, you're going to learn kind of more advanced ways with 4-term polynomials. But in Algebra 1, it's kind of just introducing it, really. Okay, so it says factor the following polynomials by grouping. So this idea of grouping, and again, these are carefully designed so that they're able to be grouped. What you do basically is we can group, I'm going to underline these first 2 terms, and we can also group these first 2 terms and kind of factor them individually. So watch this. So we have x to the third plus 3x to the second. And this kind of goes back to just factoring out a monomial. So if I have an x to the third and 3x to the second, I can factor out an x squared from those. So then I would have an x plus 3. Okay, so that's the blue part. I factored an x squared out of that expression. Now I'm going to factor the green part. So I have 6x plus 18. So the greatest common factor I can take out of 6x plus 18 would just be 6. So I would have a 6 parentheses x plus 3 if I factored what I have in green. So by coincidence or kind of design, both of these x squared and the 6 are being multiplied to the x plus 3. So I can group the x squared plus the 6. I can do this. I just grouped the x squared and the 6, made it x squared plus 6 there. It's like the reverse distributive property, right? Factoring has always been, this entire unit has been the reverse distributive property, right? If I were to multiply this out, don't write what I'm about to write. I'm just going to write it up here. If I were to do x squared plus 6 and times x plus 3, I would be doing the x squared times the x plus 3, which is like up here. And I would be doing the 6 times the x plus 3, which is right there. So it's just reverse distributive property. And as always, you can distribute to check to see if your answer is right. I've said that a million times, but x squared times x would be x to the third. X squared times 3x would be 3x squared. 6 times x would be 6x. 6 times 3 would be 18. There you go. That is the original expression we started the problem with. So, I've said it a million times, but you can always distribute to check to see if your answer is right. But I'm going to erase all this stuff because I don't want it to get too muddy on this paper and see a bunch of work flying around everywhere. I want this to be as clear as possible. Okay. All right, that was not the greatest erasing. Whatever. All right, it's fine. Okay, let me show you B. So again, I'm going to group the first 2 terms and group the second 2 terms. Now, I'm not going to go into super lengthy explanation, kind of like I did on A. I don't want it to get too confusing for you. So we're just going to group those 2 terms. So I have a 2x to the third plus 8x squared. I'm going to group what I have in the blue there. I'm going to factor that with the greatest common factor. So the greatest common factor of 2x to the third plus 8x to the second, I can factor out a 2x to the second, which would mean this would just be an x for that first term. And then I would have a 4 for the second term. And always distribute in your head to make sure it gets back to that blue underlined portion. And then for the green, I can do 5 and then x plus 4. Okay, so notice they both, and this is a way that you know you're doing it right, is that they both the 2x squared and the 5 have an x plus 4 multiplied to it. So those better match. Like on A, we had x plus 3s, and B, we have these x plus 4s. Those better match. So now what I can do, or else you made a little mistake and just go back and look to see where you screwed up. But now I can group those. That's the solution. I'll show you some more. Okay, let me group those. So out of the 2x to the third plus 3x to the second, I can't factor out a number 2 and 3. They don't have a common factor other than 1. But I can factor out an x squared. So if I just factor out an x to the second power, I'll have a 2x and then a 3. And distribute to check. X squared times 2x is 2x to the third. X squared times 3 is 3x squared. And when I underlined in green, since it's a negative 14, I'm going to factor out a negative. I'm going to factor out negative 7. Negative 7 is a factor of 14 and 21. So I'm going to factor out a negative 7. And that would be an x plus, not 2. My bad. I messed that all up. That would be a 2x plus 3. Because negative 7 times 2x is negative 14x. Negative 7 times 3 is negative 21. So I'd factor that part. And again, look, I just make sure they both have 2x plus 3s in parentheses. Like I see 2x plus 3, 2x. That means I did it right. If you don't have that, that means you made a little mistake with your factoring. And now I can group these guys. I can call this x squared minus 7 times the 2x plus 3. Shows you D. So with this one, I'm going to group those two. So x to the third minus 2x to the second. I can't factor out a number, but I can factor out an x to the second. So that would be just an x there and then a minus 2. And then I can do plus the 8x minus 16. I can factor out an 8. So I would have an x, and then 8 times 2 is 16, so minus 2 there. And again, I have an x minus 2, another x minus 2. That means that kind of tells me I'm doing this right. Those can group x squared plus 8x minus 2. So hopefully those 4 examples are good enough for you to try some of the other ones. I'm going to show H, though, because H and J are a little tricky. Just let me show you that one really fast. So group this. So in the blue underlined, I can factor out a 2x to the second. So that would be just an x and then a 6. Yep, 2x to the second times 6 would give you 12x to the second. And then what I underlined in green is super strange because there's really not a greatest common factor with x plus 6. Like, right? Like there's no, that's just a 1x. So what you can do is just factor out a 1. This may seem really stupid, but you can just kind of factor out a 1. Because 1 times x plus 6 is just x plus 6. So now that kind of allows you to group those two. So that problem's like J is like that too. So you can just kind of factor out a 1 when there isn't really any number to factor out. But yeah, do your best on the rest of them. That's factoring by grouping.